Hello and welcome back. Today I'll be going over LeetCode problem 26, which is ranked as easy, but nearly 50% of people fail this problem. Here, the problem asks us to look at a non-decreasing array in which we should remove all the duplicate elements in the array and make sure that we keep it in its increasing order. We should then also return the amount of unique elements in the array. Now, first up, I have no idea why they say non-decreasing. They should just say increasing. It makes life much easier. Next, into how we should solve this problem. The idea I want to implement here is having two pointers, with pointer A starting at index 0 and pointer B starting at index 1. And I'll be storing this under a for loop, so the pointer at index 1 increases each iteration. I'll then be comparing the value at pointer A with the value at pointer B. If they're the same, then we know that the two values are duplicates, so we can leave them alone. If they're different elements, however, then we know that they're unique numbers, since this list is sorted from lowest to highest. In that case, I want to move my pointer A to the right by 1, and I also want to take the value at pointer B and replace the value at pointer A. I'll then repeat this process until the loop ends, and I'll return the value of pointer A plus 1. Now if you're confused by all of that, don't worry. Here I'll be going step by step through what happens to this array, along with showing you the value of the pointers through each iteration. We'll start with pointer A at 0 and pointer B at 1, and our array is going to have the elements 1, 1, 4, 4, 5, 6. First, when we start, we're going to be comparing index 0 and index 1, and since the values at those indices are the same, we can move on. We're then comparing the value at index 0 and index 2, in which we're going to be comparing 1 and 4, which are different values. When this happens, we increase the value of the first pointer by 1 to shift it to the right by 1, and then we set the value of the number stored at the pointer to the value stored at pointer B. In our next comparison, we're going to be comparing index 1 with index 3, in which they're both now the same values, so we don't have to worry about anything. We then compare index 1 and index 4, which is comparing 4 and 5, and I'm pretty sure that 5 and 4 are different, so we carry out the same steps as before. We increase the value of pointer A and set the value at pointer A to be 5. After that, we can move on to the final step, which is comparing the value at index 2 with the value at index 5, which is comparing 5 with 6. If I recall correctly, 5 is not the same as 6, so we can do all of these steps again for the last time. Pointer A increases by 1, and we replace the value at pointer A with 6. By now, our array is 1, 4, 5, 6, 5, 6, but we don't have to worry about that extra 5, 6 at the end. As per the directions, it states that we have to change the array such that the first k elements of nums contains the unique elements in the order that they were present in initially, and the remaining elements are not important. Well, we have the 1, 4, 5, 6, and that's all we need. Now you might be wondering about what we're supposed to be returning. You see how we've been changing the value of pointer A? Well, what does pointer A represent? Well, if we look here, pointer A represents the index of the last unique number we have in the array. In Java, arrays are indexed from 0 onwards, so if an array were of length 5, then the last entry in that array would be at index 4. In this case, we have the index. So to get the length of the array of the unique numbers, we just add 1 onto the index. So that's why we return the value of pointer A and add 1. If we submit this code, we can see that it works. If you have any questions or any problems that you'd like me to go over, please let me know in the comment section below. Otherwise, goodbye.